Assalamualaikum warahmatullahi ta'ala wabarakatuh. In this video tutorial, I will show you maybe 2 or 3 example assignment on simulation. For your information, the software Autodesk Inventor Professional also have the capability to do simulation. They have basic and advanced method of doing simulation. In this example, in this video, I will show you how to do the basic example. So let's start with creating a new file. Click standard and create, and start with a simple sketch. Select XZ plane. Make sure your dimension is in mm, and draw a circle with 25mm dimension and press enter, and extrude maybe around 50mm and select OK. So this is the object that I'm trying to simulate for the sake of this video. There are many types of stress can be applied on top of this component. One, it is tensile, and the second one, it is compression. So I'm going to do compression, where the component will be pressed from top. So from Autodesk Inventor Professional, select stress analysis and select create study, and this one just keep it as it is for static analysis and select OK. So first of all, you need to select the type of material. So let's use cast iron. You can see the color is black, whereas it's difficult to distinguish from the background. So can we change to iron, malleable? It's still a type of iron, but has been subjected to some treatment. That's why it is called malleable. We start from the material and go for constraint. So look at the constraint option and select fix, and select the bottom part of this component and select OK. So what we have done is that we inform, or we instruct the Autodesk Inventor to say that the bottom part of this component, it is fixed on the wall or on the floor. And then select load, go for force. You can go force or pressure. In this example, I select force. Select this area on the top, and we go for 1000 Newton. Select OK. One new thing that you might encounter in this video is about meshing. Meshing is a web or lines that created to predict or to calculate the behavior of the material under certain load. The finer the line, or the smaller the line, or smaller the meshes is, the calculation will be a lot more accurate. This is a normal mesh looks like. Depending on the type of your computer, the capability of your computer, you may want to choose suitable mesh option. Choosing a fine mesh will take a lot of time for the computer to calculate, and may lead your computer to become hot or hotter. So once we're done, we can now select simulate and run. Just take a few seconds to calculate the behavior, and as you can see, if you change to front view, you can see that a line indicate the original dimension of the cylinder before subjected to the load of 1000 Newton. And this is what happened to the material once it is subjected to the 1000 Newton load. One advantage for Autodesk Inventor is that you can do some animation to further understand or to further look into the type or the behavior of the materials. So you can see how does the stress distributed when the force it is applied to the object. Select OK. You can click the function report over here and select OK. When you click this function, the software will automatically create a report indicating all of the options and the design that you have drawn into the report. I will not go into this one. I think this one you can try for yourself. So let's try for another example. Let me close this one first. For students, please save and submit the assignment. Okay, this one I just click no and start another one, new part. Still I will do a cylinder with 25mm diameter and extrude with 50mm. Press enter. Now I want to do tensile. So select stress analysis, select create study and select OK. The one material that we use right now is just iron. So check the bottom of the component and select fix for the constraint and select OK. Return to original view and then select the force and select this area, and this one we want to change the value to negative 1000 Newton. I think cannot recognize 1000. And the direction, just click over here to ensure that now the load is facing up, meaning that these samples are being pulled. That's what tensile means. If the arrow is going down, meaning that it is experiencing tensile. Select OK, select mesh and simulate. Select run. As you can see, contradict or opposite to the compression, tensile makes the material become longer comparing to the line where it is before and after. The radius of the cylinder also decrease. As you can see, there is a small differences of the line and the actual object after the load is applied. So let's select the animation so that you can see and understand what is the behavior of this material under certain load. Select OK. And I think that should be okay for this video tutorial. I hope you have learned some valuable things and knowledge in this video. So I'll see you guys on the next tutorial.